Hello everyone, myself Lalitha. In this session you are going to learn about the transportation problem. The transportation problem deals with the transportation of any product from M origins, which is represented as O1, origin 1, origin 2 till origin M, to N destinations, which is represented by D, D1, D2 till Dn, with the aim of minimizing the total distribution cost. So, given a transportation problem, the main aim is to minimize the total distribution cost. So, you have come across few terminologies here. We have origin, we have destination, and we have to minimize the cost, minimize the total distribution cost. So, for the transportation problem, there are few things required before you start solving the problem. So you have to have, see, the basic idea with the transportation problem is you will have so many origins, say origin 1, origin 2 or origin 3, and we have say 4 destinations. You have some products with origin which is manufactured by these origins or these factories or these manufacturing units, which is to be transported to these destinations. These destination can be a warehouse or a retail price shop or a wholesale price shop. Whatever the products these factories producing, you have to transport it to the destination. And from one origin, it can go to all the destinations like this. Now, we have few products here with origins, which is represented by supply from the manufacturing unit, and these destinations will have some demand at the destination. So with the supply you have at the origin, you have to satisfy the demand at the destination. And these lines, suppose if you assume these lines, that is going from origin to any of the destinations, will include some cost, that is transportation cost. So for solving any kind of transportation problem, you have to know the origins, number of origins and number of destinations with the transportation cost from origin to all the destination. Reaching from one origin to the destination will incur some amount of money or say fuel or time. So our main intention is to minimize all of these. The cost between the origin and destination is represented by a metric which is called cost matrix. So it is in the form of matrix wherein all the origins, say for this example I am writing the cost matrix, we have 3 origins and 4 destinations. So there will be some cost incurred, say x11 for reaching origin 1 to destination 1, origin 1 to destination 2, origin 1 to destination 3, origin 1 to destination 4. The same way you are writing the cost reaching from second origin to first destination, cost incurred for reaching third origin to first destination, and goes on like this. So as I told you, this origin is associated with supply. So origin is represented by, or the factory represented by, the rows. So I am writing supply here, which will give the cost or the total products produced by these factories or origin, and destinations are associated with some demand, and that should be in the column. So I am writing here. So cost matrix, there is a way to write cost matrix like this. The supply and demand should not be closed. Only this is the cost matrix. Remember, only whenever you are going to solve the transportation problem, you will be dealing with the cost, and which is here, and the supply from of these origins, and demand from these destinations. So you have to not close this matrix like this, because we are concentrating only on the cost matrix, where only this will give you the cost for of reaching origin to destination, and these are the supply and demand. Now we will see the different types of transportation problem. The first one is balanced transportation problem. Second one is unbalanced transportation problem. So in balanced transportation problem, see, I hope you are familiar with all these notations. We have different origins, different destinations, and all the origins are associated with supply, and all the destinations are associated with demand. So in balanced transportation problem, the first condition is the summation or the sum of supply should be equal to sum of demand. When you have to solve the transportation problem, the problem should be a balanced problem, or else you can't solve. So now we will see whether this condition holds good for this problem or not. So here you draw a slanting line here. So now you will add up all this supply, 20, 20, 10. This is 50. So sum of supply is 50. Now we will see the sum of demand, it's 40, 45, 50. So this is equal. So if the sum of supply is equal to sum of demand, then it is called a balanced transportation problem. So to solve the transportation problem, it has to be balanced, or else you can't solve. Now we will see another kind of problem, that is unbalanced. When you call a transportation problem unbalanced, there are two ways of checking for unbalanced transportation problem. The first one is when the sum of supply is less than sum of demand. So we will see the sum of supply is 40, sum of demand is 60. So we have imbalance in sum of supply and demand. That is, sum of supply is 40, this is 60. So sum of supply is less than. So how much is the difference? How much is it is deficit? It's 20. So you have to increase the supply to 20. How do we do it? When the supply is deficit, you have to add a dummy row. Whenever there is a deficit in the column, you have to add a dummy column. So first kind of problem is when the supply is less than demand. The second kind of unbalanced transportation problem is 70, 50. So another kind of unbalanced transportation problem is when supply is more than demand or demand is less than supply. So supply is 70, demand is 50. So the demand is less than the supply. So what are we going to do? We have to increase the column. We have to increase the demand. I'll show you how to do. This is very important. Whenever you have unbalanced transportation problem, you have to balance it. I'm going to show you how to balance the unbalanced transportation problem and then start solving the problem. So whenever we have deficit in supply, you are going to add a row. So how do we do it? So I'm adding a dummy row or DO, dummy origin. So number of destinations remain the same. I'm going to write the supply. So with the cost, this is demand. So with the cost, whatever the cost you have, I'm copying down from this problem. I'm assuming the same cost is there for this problem also. I'm writing some dummy values here. I mean some values, random values. So dummy value is always 0. For the transportation cost, remember it is only for the transportation cost. I'm copying the supply of this problem. And how much was the deficit? So 20 was the deficit to balance, in order to make it balanced. So the original demand was 20. So now we will see this is 60, this is 60. So this is how you have to balance the unbalanced transportation problem when supply was less than demand. So when you have supply more than demand, or when demand is less than supply, what are we going to do? We are going to add a dummy destination. So destination 1, destination 2, destination 3. I'm calling it as dummy destination 4. So this is supply, this is demand. The cost remains the same, but for the dummy value, okay, let me write, don't get confused, because if you don't have if you don't have balanced transportation problem, your results will be wrong. So I'm adding this cost is 0, but you have to balance the demand, deficit demand. So it was 40, 20, 10, 30, 10, 10. How much was how much was deficit? It was 20. So now we will see 30 plus 40, 50, 60, 70. 40 plus 20, 60 plus 10, 70. So now supply is equal to sum of demand. Here also sum of supply is equal to sum of demand. So now the transportation problem is balanced. Now we will see how to solve the problem, transportation problem, in the next video. Thank you.